Good afternoon, everyone. I'm Nicole Henderson, editor at the WHIR, and I'd like to welcome you to today's webinar. Today's session is called Shoot for Savings. Find out how HP.com handles 300 million hits per day with HP Moonshot. And it will be presented by Volker Otto, IT Director at HP.com. I will let Volker introduce himself and HP properly in a moment, but before I do, I want to take care of a couple of things. First off, questions. We're going to save some time at the end of the session for your questions, but you can submit them at any time using the question function in the webinar software. If you ask a question and it doesn't get answered, somebody will reach out to you by email after the webinar. Or if you have a question you'd rather not ask in a public forum like this, there will be some contact info on screen during the Q&A period, so you can reach out that way as well. Finally, there will be a video archive of the webinar available if you want to rewatch the presentation or share it with someone else. It will be in the archives at thewhir.com/webinars by the end of the week, so make sure to check that out as well. All right, let's get started. Welcome, Volker.
Thanks, Nicole. So before we get started with the content of the presentation, let me first thank you for having me today and giving me the opportunity to present our incredible journey using HP Moonshot in production at HP.com. So before we go there, let me give you a little bit more context around my role in HP and from what vantage point I give you my feedback here. So I'm not part of the product organization in HP. I'm part of the internal IT organization reporting up to the CIO in HP, and as part of this internal function, my customer is HP, the company. I'm responsible as the director for platform services and automation within our infrastructure organization. I am responsible to make sure that we have a 24/7 support of our x86 Windows and virtualization platforms for HP as the customer. So I'm really an end user from a product perspective, and I'm in the lucky position to have my main provider of my hardware platform sitting next to me within the same company. So that partnership with the product organization is very crucial for us, and it helps us as an infrastructure organization to basically get the latest and greatest from our product teams, but also influence the product development as a feedback loop for the product teams. And the engagement in the Moonshot case here is exactly this type of feedback loop. So before we go into what happened and what we did with HP.com, let's get started with a quick overview for those who might have heard the word Moonshot but don't really have seen, neither touched the environment yet, and want to understand why this is so incredible and what's the real deal from a hardware perspective. So when you look at Moonshot as a system, we really talk about a new form factor, a high density computing, a new design revolutionizing the space and power consumption within the data centers. So instead of having 1U units, one server each, or HP's blade units where you have up to 16 blades in an enclosure, here we talk about a 4.3U unit which hosts 45 hot plug cartridges, and each of those cartridges represents a server on its own. The concept is really, really neat when you have space and power constraints within your data centers, because you basically stick 45 servers in a 4.3U space within your racks. And that's really nice that not only this gives you a high density from a form factor perspective, but also think about all the cabling, all the connectivity, everything is built in within the chassis. So you have two switches in the chassis and the cartridges basically plug in, and you don't have to do any cabling in any of these maintenance and configuration activities in that space. So that itself was very interesting for us, because as a data center provider, my main concerns are space and power and network within the data center. And as any other provider, we constantly try to optimize the footprint so that we run the optimal workloads on an optimized footprint with the least amount of power and within the least amount of space. And that's really where Moonshot is a game changer. And the product team reached out to me over a year ago when we were in the final stages of launching the product to help with running a use case to show the power and great concept of Moonshot by running a production environment within HP. So we were looking at the different applications we have and settled on why not go with our main flagship entry into the web domains for HP, hp.com. So as any hosting provider, when you look at a major domain like hp.com, you don't talk about one application. As you all can relate to, behind the root level domain we have here, there are hundreds of applications. In our case, hp.com covers approximately 100 applications. We have about 8,000 to 10,000 domain names out there in the internet, which you can think of, the country domains we own for HP, the several product and marketing domains we have, and a lot of subdomains for product information, for downloads, all these type of information we share on the internet. We also have a long heritage when it comes to HP, the company. So on our journey over the past 70 years, we basically picked up a couple of other companies. Think about Digital, think about Tandem, think about other companies we had. And in that space, we also run those URLs and websites and domain names continuously within our web space. And all those applications basically make up hp.com. So what I want to make clear is that we haven't put all of this onto Moonshot, but we looked at our two top-level applications from a traffic perspective, and those are what I call the browsing application, which is www.hp.com, and I really refer to that one as the gateway to HP's web presence. When you as an end user hook up to HP and you want to basically find out about our products or offerings or just want to look for a driver or something, you basically would start with www.hp.com. So this is really the gateway to HP's web presence. The other major domain, which was neatly co-located on the same set of servers, is the ftp.hp.com domain. And that is generically referred to as the download website. And when you think about it, we have a lot of products and we have a lot of product information and drivers and white papers and updates which will and are made available for download on that URL. So what we do here is basically we have a lot of manual downloads by users proactively going through our pages and browsing and basically selecting, okay, I need this driver for my HP product. And we have automatic downloads via the HP software agent, which is installed on each and every of our desktop and laptop computers, but we also have automatic downloads happening from our printers and other products we have. So a lot of the devices, for the lack of better words, phone home and basically update their firmware and their device information using ftp.hp.com. Most of that traffic is happening via HTTP, but we still have FTP as a protocol for people who basically connect to the doc root under the FTP server under ftp.hp.com. So we have both types of traffic happening in that space. So why were we going with those two flagships? The answer is very easy. When you look at Moonshot and the setup of the first product generation, we were talking about a very lightweight cartridge, for the lack of better term. So we were talking about a 2-core, 8 GB of memory, up to 1 TB of local storage cartridge. And that basically gives you some scaling range of what type of applications you can run on this lightweight server platform. And we were looking for a highly scaled out, very simple set of applications. And those two hit the mark right away because they're basically set up in a massive scale out way. So we have a couple of dozen servers running those. And they have a very fine-grained load distribution and traffic management in front of the server farm. And they really are not more than one layer deep from an application stack perspective. So it's really Apache or FTP running on those boxes. There's no database, there's no session handling, there's no real complex application infrastructure. So introducing Moonshot into that mix was a relatively easy process, and given the timelines we had for those projects, we could achieve the implementation of Moonshot cartridges within our live environments within a very short time frame. So let me switch to the next slide here to give you a rough rundown on how we approach the implementation, and then we will dive into each of those steps for a little bit more information about what we did in that space. So the first step we did, because we had a very short timeline to implement, we were looking at our content, and we were already thinking about introducing a caching layer into our environment so that we could relieve the Apache servers, which we were running in the data centers, from constantly providing the same type of information. You all know what the benefits of caching are, so I will not go really deep into why we did it, but we decided, hey, let's use the cartridges and their memory to serve the most wanted information, the most popular files out of that memory as a first step. And we will talk about that in a second. The second step then, after we introduced the caching layer, was really going down to the content of the website. So everything which couldn't be cached, everything which we were basically not storing in the caching layer. And as that, we addressed the Apache and Cherokee layers and VS FTP daemon layer in our environments next, so that we basically really had the web server itself, the FTP server itself, running on Moonshot cartridges. And last but not least, HP IT runs 6 data centers for the company, and we basically replicated that setup across the 6 data centers and started to retire the legacy servers to really see the reason fulfilled while we're doing all of this, which is space and power consumption reduction in our hosting environment. Okay, so let's get started with the caching implementation. So what was the picture before we started to introduce the Moonshot cartridges into the mix? So as a user, you would come to www.hp.com and ftp.hp.com, and basically you would go to a intelligent traffic management system, which is basically a DNS-based global load balancer, and you would have gotten as a reply for your request an IP address of one of our existing servers. So the existing server farm in the data centers comprises out of Itanium RX 8640 servers running HP Unix and Apache and VS FTPD. So we started with one data center, and for that one data center, I just have the power consumption on the left side as my main mark I want to point out during our presentation here. And what we did is basically, so standard way, the people connected to those servers, they did their browsing or downloads via HTTP, or they did the downloads via FTP, and were basically using the website as intended. So now, how did Moonshot come into the picture? So what we did is, because of the highly load-balanced environment, we were thinking about introducing the caching layer I was mentioning earlier, and putting those caches in front of the existing Itanium servers to see how much or how many connections each and every Moonshot cartridge could handle, so that we got an idea about how much load we can send to the Moonshot chassis to sustain the traffic we are getting on www.hp.com. And we have these 300 million hits in the title, and I will show you how we got to that number. But basically, the browsing traffic of those 300 million hits is about 100 million hits per day on the 6 data centers. So across the 6 data centers, we have the 100 million hits a day. And we were now starting to introduce cartridges within one of those 6 data centers. And the load balancing actually allowed us to dial the traffic in a way that we started to send 5% of the traffic for that data center over to the cartridges, and then we could basically dial up and down to get an idea about what type of load they can sustain. So bold as we were, we basically said, okay, we have 6 RX 8640s handling the traffic right now, so let's take 6 cartridges, those tiny 2-core, 8 gigabyte of memory cartridges, and compare. So we have it's not a real apples by apples, but it is at least a fair comparison from the amount of server perspective. So what we did is we put those 6 in the mix. We ramped them up with HA proxy and varnish and started to send traffic that way. And within half an hour, running on those 5%, we were like, okay, doesn't look too bad. They were basically humming along just fine. So we upped the traffic to 10%. Still no change. Servers were holding up just fine. They were starting to cache. We had about 70% cache hit ratio. So we saw the traffic dripping off from the existing servers and moving over to the cartridges. Okay, so we went bold. We put 50% of the traffic over. Still, cartridges were just fine. Everything worked. They were holding the traffic. They were serving the bandwidth we were seeing. And so by the end of the testing period of about 2 hours, we were basically sending 100% of the traffic for that data center, for browsing, for the www.hp.com URL over to the 6 cartridges, and they were just doing fine. So that really, blew us away. That was really like, wow, they are doing really better than we thought from just looking at the specs and everything. So we were watching this for the next month just to get a good feeling for the traffic. And what I will show you here is basically, I know it's a very, eye chart, but basically for this proof of concept, as we termed it, although it was production traffic, we were looking at this for a month, and we were basically seeing the impact of the moonshots here. So we were starting on April the 8th last year, and when you look at the traffic picture, and I just showed this picture to our customers because people always ask about these 300 million and how we came about that picture. So when you look at the lines here before we look at the stack graphs, the lines represent the traffic from 2 years ago by now, so April 2012, it's the orange line there. And then you see the green line, which was the actual traffic a month before the proof of concept. And they both hover in between the 250 and 300 million hits mark every day. So it is really a representation of a typical day on the HP.com farm. And we basically have the couple of, or the different types of traffic as I mentioned them earlier in the presentation. So we have the, what I call the www hits, so that's the browsing traffic. And this is the red bar you see down there hovering about 100 million hits per day. And that was the traffic we were introducing the 6 Moonshot cartridges into. So as of April the 8th, you could see that you have that little light gray, bluish graph down there, and that's a representation of about 1/6 of the overall 100 million traffic. So we're talking about 12 to 16 million hits a day being taken by those 6 cartridges. So the 6 cartridges basically handled each between 2 and 3 million hits a day from a pure traffic perspective, from a pure connectivity perspective. So that was really, really encouraging. The other numbers you see here are the, what I call the www publishing hits. So this is another 100 to 130 million hits a day. And these are the HTTP downloads, people downloading files from the ftp.hp.com domain using HTTP as a protocol. And then the remainder in purple up there, which is about 40 million per day, are hits we getting to a separate environment sitting next to the existing www and FTP environment. And that's the dynamic part of the web experience under www.hp.com, which handles the driver selection when you need some dynamic information on the web pages. But just to have that complete picture, we were basically showing this here. Okay, so let's get going. So after we had the caching working, we were now going after the real web server and FTP serving. And this is the current setup within the chassis for www.hp.com and ftp.hp.com. And I have to tell a little bit the story of our content itself so you understand why we have it split that way. When I look at my total amount of files I serve via ftp.hp.com, we talk about roughly 5 terabytes of information. So you heard me earlier saying that the cartridge itself comes at the most with a 1 terabyte disk drive attached to it. So I had a problem. I had to fit 5 terabytes into an environment which can only serve 1 terabyte local from each of the cartridges. And there are multiple ways to go about it. And honestly, we tried multiple ways. So the first way was to, can we split the traffic? As in, can we split the content into different subdirectories and then serve those subdirectories? That would be the preferred method. But the problem was really that from a maintenance of the content platform itself, as in replicating the information across the 6 data centers, and in this case now across a potential hundreds of servers, is an administrative nightmare. So we tried to avoid splitting it up into different subdirectory information and rather come up with some form of network attached storage so that we can basically show a drive letter, or if you wish, a mount point to the web servers and FTP servers as one single mount point, as we were used to from our Itanium servers. And first we tried with running this inside the chassis with a cluster setup, which showed us some of the boundaries of using these lightweight cartridges for more CPU-heavy traffic. So we were basically starting with that. The cluster worked in a lab environment, but it didn't work with the traffic numbers we were seeing to the FTP website. So ultimately we settled on a hybrid solution right now, where the NFS for the content is provided using our existing server farms, the Itanium servers, and using the Moonshot cartridges as the front end to the end customer, providing Cherokee and VS FTP vsFTPD for the FTP downloads in that space. So on the left side, though, for the www.hp.com space, we were really excited about the caching, as I mentioned earlier, and we could even dial down the amount of cartridges we need to handle the traffic. So we started with 6, as I said earlier, but we are now down to 4. So those 4 cartridges really handle the end user connections. And then we have a ratio of about 1 to 2 to 1 to 3 between a caching cartridge and a Apache cartridge running the actual file system for the document root for the www.hp.com. That file system is about 900 gigabytes, so it fits on the local drive for each of those cartridges. So that's why we have the content replicated out across those 8 cartridges and can run this completely within the chassis. So the interesting part really is that I went from Itanium servers to about 12 cartridges per side. So let me go forward here a little bit and show you the before and after step. So as I said earlier, we were caching the content and we had the file fetching for the non-cached and non-cacheable objects coming from the existing Itanium servers, and we were basically serving the FTP content from that side. Again, when you look at the power consumption for each of those environments, we talk about 3.3 kilowatts per server on the left side, and we talk about 19 watts per cartridge on the right side. By the way, if you have ever heard our CEO, Meg Whitman, coin the term that HP.com runs on the power of 12 light bulbs, this is where it's coming from, because in the beginning we had these cartridges serving the caching content, and basically you can compare one cartridge to a 20-watt light bulb. So just in case you were wondering where this phrase comes from. So now let's go to the next step here and show how it's set up now, as I said earlier. So we have now this proxy caching layer, the Apache layer for the www, and then on the FTP side of the house, which is those additional 100 to 130 million hits a day, but a lot more bandwidth, as you can imagine, because we're talking longer term file downloads. If you own an HP product, especially printers or other products from our side, you know that our drivers tend to grow in size. So it's not unheard of that we have driver packages which are 2.3 or 2.5 gigabyte. And when people start those downloads, of course, you have a real longer time to download that file versus a simple browsing on the website. So as said, we're now serving this out of the farm, out of the chassis, and we're only using 2 Itanium servers instead of the 6 before. And those 2, their core function is to provide that NFS, which houses the content itself, and our FTP serving servers basically mount to fetch the content for the FTP downloads and HTTP downloads to ftp.hp.com. So that's the current setup we are running. And now it's really about looking at that environment. So we run it for about 8 months now and are really happy with the setup. For those who are interested here, I basically just jotted down the traffic flow a little bit more so people understand how the traffic goes through the different environments. So we have the front ends with the HA proxy and Varnish. Everything runs on Linux 6, by the way. I know that I was mentioning we were running on HP Unix before. So as a nice side effect of this project, I got my HP Unix to Linux migration done at the same time. So just as a side note. So again, running on Linux, HA proxy, and HA proxy then basically uses certain rules for load balancing across the Apaches and serving traffic out of Varnish from a caching perspective. As I said earlier, the cache hit ratio for the website is about 70%. So those 4 cartridges really handle 70% of the connectivity requests, and then the rest goes down to the 8 Apaches we have sitting in the back end. And then on the FTP side, as said, if you browse our environments, you will find the /pub directory for the FTP content, and that goes to 18 Cherokees right now, and they then load the content via the external NFS. Okay, so with that, let's look at the final step, which we are right in the middle of, and working basically to replicate that picture across all the 6 data centers we have. We have www.hp.com running in those 6 data centers as of August last year. So it's all done. FTP is currently being moved into the different data centers. But basically, you simply replicate that picture now into your data center locations. I know it's a very, archaic, very simple setup, but it buys us a lot of resilience. It buys us a lot of fault tolerance in HA, and our content management systems in the background are able to keep up with keeping all those cartridges in sync from a content perspective. You can definitely do this, with dynamic hosting in a total different way, but it's the setup we have, it's proven, and it serves the purpose from our perspective. But let me show you the real nice effect of all this, which is the savings in power consumption and the savings in space. So when you look at the before situation, we had 46 legacy servers, so mainly RX 8640s or in that space, so large hunking boxes. You can fit about 2 of those into a rack in the data center. And that's what we normally did. So the total power consumption for those data center rollouts we have was about 115,000 watts. So now we reduced all of that. When we are done with the project, basically the footprint looks that we have 6 Moonshot systems, so 6 chassis, 1 per data center, and we have 12 legacy servers left over from the original environment due to the provisioning of the NFS mount point. You could argue from a project perspective, I can still do an NFS with a different server setup, but it was more of a convenience story and having the hardware at hand versus going all out and buying even new servers for the NFS mount point. But you could optimize the picture even wider than what we did. But in essence, we already got it down to each of the Moonshot chassis consumes a total of about 1 kilowatt. So all 45 cartridges together, all lit up, running with the 2 switches, the chassis consumes 1 kilowatt. So I'm down to 6 kilowatts for all of the 6 data centers. And then the legacy servers are about 30 kilowatt still in power consumption. But also from a space perspective, you could fit 6 Moonshot systems, Moonshot chassis within 1 rack. No problem. You can fit up to 8 to 9 of those chassis into a rack, depending on your rack configuration. So we basically went down from 23 racks to theoretically 1 rack. And that is huge, especially if you have data centers which are overly crowded. That is a huge benefit right out of the gates. And that's really what's the beauty about this environment. So this is where we calculated our savings, 69% less space, 69% less power. And you can achieve much more if you run in a different configuration than we run for this very special use case here. So that's why those numbers are rather low end from what you can achieve. And depending on your data center configuration and the way from where you come from, you have different outcomes, but it's an amazing result already, and we are definitely going forward with putting Moonshot chassis into our data centers and starting to move other web applications out of the HP.com family onto the Moonshot server platforms. One of the examples, which I don't have here in that presentation, but which we just did recently, is our channel partner website, so it's partner.hp.com, and the front-end web layer moved away from what we call the standard hosting model over into a Moonshot-based web layer and is running there ever since. So we are starting to address other applications out of that family of applications we have. So let me close the presentation with some additional information for you to how you can join the Moonshot community. So if you are thinking about investigating workloads, working with HP to benchmark applications and to maybe run your workload, you can reach out to the Moonshot Discovery Lab environment and reach out there to work with the product team and work with the pre-sales experts of HP to get your workload running on Moonshot and get results you then can translate into what it would mean for your production environment. So I really encourage you to reach out and give Moonshot a shot. It was really doing great for us inside HP IT, and it definitely has its footholding and footprint within the web hosting space right away out of the gates. If you want to know more about Moonshot itself, go to hp.com/go/moonshot and you will find all the product specs and information and white papers there. And with that, I would open it up for questions. Back to you, Nicole.
Okay, thanks. All right, so as Volker said, it's the perfect time to ask questions. You can do so by submitting your questions right within the webinar software, so feel free to do that now. We've got some questions now, so I'll just get started here. So the first question is, how difficult was it to integrate Moonshot into your day-to-day data center operation?
It was not difficult at all because the cartridges itself are like any other x86 server platform. So we were using our standard Linux server operating image we use for ProLines within HP IT, and we could use that image right out of the gates and put that image onto the Moonshot cartridges, and we were basically able to, with that, use the same monitoring, the same operation guidelines, have the same server support organization, look after Moonshot cartridges, and it was a seamless integration within our overall server management framework.
Okay, great. The next question we've got here is, can you run your standard operating system on Moonshot?
As I just mentioned, yeah, you can. So basically it's the same Red Hat image we used. You can have other Linux distributions running on Moonshot. We, inside HP, standardized on Red Hat Enterprise Linux. So our Red Hat 6 image was used. As I said, we didn't have to change anything from a image perspective. And then we also certified Windows 2012 and Windows 2012 R2 for the next generation of Moonshot cartridges. So not for the one I presented today, but for the M300 cartridges, we not only run Linux, but we also have Windows certified so that we can run Windows workloads. And again, it's the same certification process as we do for other ProLine servers, and it's literally the same setup from a image and build perspective. Okay,
great. The next question we've got here is, how do you select applications running on Moonshot?
So that's a interesting question, because I get this all the time when I present what we did with HP.com. How did you decide that the workload fits? So in general, it's obviously on a case-by-case basis. So first and foremost, you need to do load testing. You need to look into your application and into your application stack to decide if it would be a good candidate for Moonshot. But in general, I think I found about 4 criteria which I use right now when I comb through the list of applications I have inside HPIT and see if they could be a good candidate to run on Moonshot. The first is really, is it a scale-out application? Especially with us here in the web hosting space, we have a lot of those applications which can run on multiple instances at the same time. So if you have one of those which are load balanced, stateless if possible, are replicated setups where you can lose a couple of nodes or compute cartridges and your application would still run, Moonshot is a perfect platform for you because it's similar to other lightweight footprints. You basically put the load onto, let's say, 50 or 100 or 150 nodes, and those scale-out applications are an ideal candidate. The second criteria I looked at was, is it a mainly memory-driven workload? Given the CPU specs for the first generation cartridges, given that it's a lightweight atom, we were looking into, okay, what can we do out of memory and make sure that we have enough CPU power to do the memory operations and don't stress too much of the content going to the file drive, to the drives and doing file I/O and stuff like this. So we were really looking into caching, load balancing, reverse proxying, these type of things where we didn't have a lot of file writes going onto the hard drives and basically could do a lot of the stuff out of memory. The third, and this leads me basically into the third criteria, is is your content small enough or does it fit onto the local disk? So ideally, the NFS solution we did for FTP is really a hybrid, and it's not an ideal setup for at least from a first generation cartridge perspective. But we had to do this because of our content size. But if your content fits within the 1 terabyte, then yeah, it's a candidate. It definitely is something you can run out of a Moonshot cartridge. What we saw is the performance, as long as it's a local drive read-write, is really good enough for most of the web workloads we have. And then the fourth criteria is the bandwidth requirements, of course. Given that we have 2 1 gig NICs within each cartridge, as long as your overall bandwidth need is within that boundary, it's a candidate. You can put it up there and they serve up the traffic nicely. As I said, they hold these connections we have for downloads and they serve the different millions of hits we have per day nicely using that network capacity. You have to understand that with upcoming cartridge generations, these capabilities only increase. So the second generation we have right now with the M300s, those already have a more powerful CPU setup and they have more memory, 32 gigabyte. So that gives you another shot at other workloads which weren't fitting into the 2x8s we had with the first generation, but now maybe fit into the 8x32 or 4x32 given the cartridge type you are looking into. So it only grows, and the candidate list for applications will only grow over time, and that's what we're really excited about as an IT organization, as a service provider, not because we're HP, but we're really excited about seeing the growth and capabilities with the upcoming cartridge generations. So there will be definitely more criteria where you start to see that maybe CPU is not a limiter anymore for an application. I know, long answer, but it's, as I said, it depends on a case-by-case basis for your application.
Okay, thanks. So the next question I've got here is there a standard rule to scale Moonshot systems?
As said, it really depends on the application. I wouldn't say there's a standard rule. It really depends on what is your current system configuration. When I present at conferences, for instance, people ask me, yeah, you have an easy case because you use Itaniums as your start. Point taken, but we were able to replace those hunky boxes with, the cartridges, and so it's a very, favorable case for a savings perspective. But you can also look at comparing, let's say, a ProLiant DO360 or 380 with Moonshot cartridges, and you might end up at a different result depending on your application. So it's really hard to give you a rule of thumb and say, given a DO380, you can replace whatever workload is running on there with 5 to 6 or 8 cartridges. It really depends on the workload. So what we've seen is that from the Apache workloads with the Itanium, we could replace 1 to 2. With the FTP workload, we replaced 1 to 6, 1 to 8. So it's really difficult to give a general rule of thumb, and load testing is your friend here. You really need to run your own tests and spec out your environments.
Okay, thanks. So it looks like those are all the questions we've got. Is there an email that the attendees can reach you at in case they come up with a question after they sign off this presentation?
Sure. My email would be my first name dot last name, so volker.otto@hp.com.
Okay, fantastic. All right, well, that's all the time we've got for today. I'd like to thank you, Volker, for the presentation. We learned a lot about how HP.com uses HP Moonshot. I'd also like to thank everyone for attending and for submitting your questions. And yeah, thanks again, everyone. And don't forget that this webinar presentation will be available in the archives. It's the WHIR.com/archive, or sorry, /webinars. And you should also get a follow-up email from us as well in case you want to revisit a slide or send it to a colleague that couldn't make it. Thanks again, everyone, and have a great day.